The split here is the security story. Attesters, they attest to blocks and they decide what's true. They never touch the destination chain. Relayers, they don't touch the relayers, they touch the destination chain, but they don't get to decide what the message is. They cannot even change one byte or the signatures won't match.
Welcome to this discussion about Attestcoin. We're going to be seeing our new powerful cross-chain communication hub. We're going to be talking about all things Attestcoin and how the smart contract can securely read data from other chains. I am joined by David, our chief software architect, Dylan, the tech lead at Attestcoin, and Beqa, one of the core developers. We will be talking about first about Attestcoin, which is our solution to the cross-chain interoperability problem. And it's a decentralized oracle. And so a protocol that lets the builder use, like I mentioned earlier, verified data from another blockchain. So it could be Ethereum or other chains that we will be mentioning during the discussion. And the main components on the right side there, you can see we have the attesters, the ATC token, ASC smart contracts, and something that we call readability and writability. And you may also have seen USC before, so that's the way we used to refer to what we now call Attestcoin. So the system at a glance, those concepts here you're going to see a few more times during the discussion, but just to have an idea, an overview to start with, the attesters are watching a source chain, and once they peer together, and once they reach the quorum, submit to something that we call the attestation chain, and we have a way once we receive a proof in a contract to verify that against what already has been verified, and so the builder can use those values and trust that they were verified. And we also have another set of functionalities that we refer to as writability. So a few ideas to keep in mind here is going to be readability, writability, and the attesters is a core component that we will be discussing. Before we go in more details about the attesters and all those components, David will explain to us some challenges that come with working cross-chain.
So why is cross-chain hard? The first thing to understand is that blockchains didn't communicate with each other because originally we only had one blockchains, and blockchains are very good at securing transaction in its own ecosystem because it has the ability to verify every single transitions inside its own ecosystem. As soon as you want to talk between two blockchains, well, there is actually no standard for doing so. So essentially, the blockchain B has no understanding of the state of the other blockchain and vice versa. So you have to develop protocols. And usually this is where the weak point starts to be, is that there's a trust models in those protocols, and the weakest point is not the two blockchains, but it's actually the consensus in the center. So this is where things starts to go bad, or wallets get stolen funds, or maybe there's a bad replay protection and it's not strong enough essentially. So this is why blockchain or cross-chain, is hard. So now we're going to try to compare what is different between Attestcoin and all other cross-chain protocols that people are familiar with. So most cross-chain protocols are message-centric, which means that they're trying to allow two blockchains or two contracts on two blockchains to talk to each other. They don't have the ability to just verify or read data from blockchains. They really can just say, this message was indeed delivered by this sender, was emitted by this sender, and I'm receiving it, and I trust this sender, so I will trust that the message is correct. Usually they have this intermediate client that is voting on the content of that message, and essentially they're only allowing you to make sure that the message is correct. Now, a lot of those protocols are built on top. they need a very tight trust. And because of that, there's a limited amount of interoperability that can happen. That's because it's not like, oh, you can change another person's contract to emit messages when something happens. So only really the custodial of those contracts can send messages. So where Attestcoin is very different is instead it will compress the evidence of all the blockchain onto Creditcoin, and then you can submit proofs on top of it. So you can really use the whole content of the other blockchain, regardless of who is emitting this message or who is doing this interaction and whose contract is receiving this interaction. And that's very different. Yeah.
All right, thanks, David. And we mentioned earlier the attester. So we are going to see again during the rest of the conversation that it's a decentralized off-chain worker. And as we mentioned before, it observes new blocks from a source chain, compute Merkle tree, and propagate that information to its peers. And that submitted and verified on chain, and it's available from there. And so essentially on the right side there, you can see the four main component here, which are observing, compute the Merkle root, and propagate that and submit on chain. Beqa will be telling us more about how that works for what we call readability.
Yeah, hi guys. I'm going to be talking about a bit more in depth about readability. I'll try to give you a bird's eye view of the whole system. And in reality, it's pretty straightforward 4 steps that the component of the attester has to perform in order to achieve readability. And those steps in order are, first of all, watching the blocks on the source chain, which in our case is Ethereum mainnet for now, but we plan on expanding upon other networks as well. So the attesters observe the latest blocks and latest head of the Ethereum network. They observe the events, the transactions, etc. Second step here is the maturity delay, which is an important security measure from our side, which in essence means that if you only listen to the tip of the chain, that doesn't really mean that you have a finalized canonical block to the blockchain added, right? Because there's always a risk of reorg, which would invalidate all the transactions inside the block. So we have a reasonable amount of blocks that an attester needs to wait until we decide that the block was finalized and added to the canonical chain. As soon as that maturity delay has elapsed, the attesters get onto the third step, which is signing the attestations and gossiping their signatures across the network. Network being the attester gossip network. As soon as this attestation reaches a quorum of 2/3 plus 1 of the active attester set, a aggregated signature can be created from all the attesters participating in a voting round, and that encapsulates into a one signature that is super simple to verify, both compute and technically speaking, and the verification process scales. You have to verify one signature regardless of how many signees you have per attestation. That's the great thing about BLS, and pretty cheap as well. And once the once the attestation is created, it gets submitted on chain. And the process of verifying of the thing on the runtime on chain leads us to the attestation being included on chain on Creditcoin. After that, a transaction can be now verified on Creditcoin from a different chain, and that essentially encapsulates the readability. So we can verify an event that happened on a foreign chain straight on Creditcoin without leaving Creditcoin. Now we'll discuss a bit more into detail how this process works visually. So up top, you can see that there's a source chain, Ethereum, which with the blocks in there, with events inside the blocks. The attesters observe them in a passive manner. They don't need to be active or like no consensus right now. As soon as they get the maturity, they get there, they start signing the transactions and gossiping the votes across. And once the quorum is reached, they submit the attestation onto the chain and one aggregated signature, which is verified on chain and it's stored there. And after that, the attestations can already be used to generate the Merkle proofs, or Merkle plus continuity proofs. We have a component, have an API which we maintain. You can use that to create your proofs, as well as spin up your own version of the proof builder and use that thing to generate the proofs. And once you have the proof, you can use your ASC smart contract to essentially utilize and verify anything you want that actually happened on a source chain onto your side. Now, important thing here is the continuity proofs, and this part helps us trust the history rather than be paranoid about it. So the continuity proofs and the attestations essentially form an unbroken hash chain from genesis of the source chain till the latest head or latest attested block. And if any actor wanted to sneak in a fake event inside the attestation chain or the hash chain, they would need to redo all the computation from genesis up to that point, and then from that point the snuck in event onwards to the latest head, which is computationally infeasible. And not to mention the decentralization part, where you would need, a bad actor would need to get the access over 2/3 plus one of the whole network, which again in a decentralized system doesn't really happen. So this saves us from history rewrites, fork substitutions, and history gap attacks, and that pretty much wraps the overview of readability. Thanks a lot.
Yep, thanks, Beqa. So Dylan is going to tell us about the second big part of Attestcoin, which is writability.
All right. Yeah, the protocol is two parts. So there's readability, which Beqa already talked about, which is live on Creditcoin today. And writability is what's in development. It's the same machinery. It's just pointed the other way. Now, a Creditcoin contract can make something happen on a source chain, on a destination chain, settle a trade, release funds, update some states. And here's why I keep calling it a protocol and not two separate products. Like both directions, they use the same attesters, the same operators, the same peer-to-peer network. So let me guide you through a message on writability sides. First, you have the publish on the outbox. A contract on Creditcoin wants to make something happen on another chain. Obviously, it cannot talk to the other chain. Chains don't talk to each other. So it drops a message into the mailbox, which we call the outbox. Second, validation. Our attester is already watching the chain for readability. So each one of their own sees the message on the outbox land and finalize. So they sign it and then they gossip the signatures. And when they reach majority consensus on the message, the relayer will pick it up, which is the third step. It will pick up the signed message and drop it on the destination chain inbox. The relayer is only a courier because it just grabs a message from the peer-to-peer network. It watches the network and it carries the envelope. It doesn't get an opinion on what's inside of the message. And then fourth, execute. The inbox checks the signatures against the tester that it knows, and only then, if it checks out, it hands the payload to the target contracts. The split here is the security story. Attesters, they attest to blocks and they decide what's true. They never touch the destination chain. Relayers, they don't touch the relayers. They touch the destination chain, but they don't get to decide what the message is. They cannot even change one byte, or the signatures won't match. That's how it's done.
All right, thank you, Dylan. And we have mentioned earlier, we have a utility token, so we call ATC. The role, so you can see here on the right, so related to attester stake and slashing, rewards, and also fees that we have for writability. And so we still have CTC there, that's used for the gas of Creditcoin, the blockchain where we are operating Attestcoin. So ATC is more specific to Attestcoin features, in other words. Here we have an example of something that we are building on Attestcoin. David is going to tell us about the commit chain.
Thank you. So Creditcoin consensus uses a proof of stake consensus, and proof of stake consensus, even though are proven by now, still have an idea of centralization risk. So the idea is to create a double layer consensus. The double layer would be much slower than the first layer of the consensus. So how would you do this is you would take essentially an interval, let's say 10,000 block, and you would, at each 10,000 block, you would take the block hash of Creditcoin and you would submit it on Bitcoin. At least that's the idea. And then people can verify if Creditcoin at a long interval of 10,000 blocks has not been tampered with. If you go to the next slide, we can see that how could this use ASC is that it could be that the committer would essentially submit his commitment to Bitcoin, which is a proof of work chain. And the attesters would wait for some maturity delay similar to what Beqa said in the other slide. This on Bitcoin could be between 3 and 12 blocks, depending on how severe we want to be with probability there. And then once this is done, you can submit a ASC proof on the commit chain DApp, essentially, which would be using the attestation chain of Bitcoin to verify that the commitment matches the hashes at the interval that we expect. And because of commit chain, you can do this without any other oracle that would verify that the Bitcoin commitment was correct or that the first is the winner. You can all do this just by other people submitting transactions and being purely protocol in a contract. And this is thanks to the Attestcoin Protocol, essentially.
All right, and we will be going briefly on a roadmap. We have mentioned that we have readability on testnet since many months, and more recently we have it on mainnet as well, where we support Ethereum. We're working in parallel on Writability, launching the ATC token, adding more type of chains and also chains of type that we already support, and commit chain, as David just mentioned as well. We have a few questions here, so we will first be talking about how can we take a contract and turn that into an Attestcoin smart contract. How does that work?
I can tackle this one. So ASC, well, this process is not as hard as it looks at first, I think. In reality, ASC is just a Solidity smart contract. It's not from another world or from another language. In theory, if you start interacting with what we have on the readability or writability side, you already have an ASC at your hands, and you essentially inherit a base contract. And then on top of it, you add your business logic to it. And yeah, you basically listen to some sort of events. As soon as the event that you're interested in is emitted, you either submit the request to generate a proof for it from Creditcoin, and then you take that proof, you decode it inside the contract, and we provide utilities to do it. And you can use the decoded proof for the information that you wanted and use it in any way, shape, or form that you prefer. So yeah, regular Solidity smart contract with a couple of add-ons from our side. Pretty modular. That's what ASC is.
Mm-hmm. Excellent. Makes sense. Thank you. We have here what's the difference between USC and Attestcoin. USC is the way we use to refer to Attestcoin. So Attestcoin we use for the protocol, for the token as well that we call so ATC, and also for the Attestcoin smart contract. So it's the way we used to be calling Attestcoin Protocol. Here we have what can we be sort of doing today? What can we be reading today? And what is next?
I'll go next for this one. So you can read state from Ethereum today. In the future, we will be supporting more source chains, different ones, and EVM potentially. And in the meanwhile, we're also working on the commit chain for Bitcoin. And of course, writability, so you can write to other chains.
Mm-hmm. All right, thank you, Dylan. Here we have, so what type of apps, what would this be good for?
So ASC, obviously, because it's chain-centric and not message-centric, it can do everything that message-centric was able to do, because essentially you could just treat an event from any contract as a message, because all the events are tested for. So it already can do like bridges, cross-chain swaps, or anything that those protocols could already do. But it could do something that is hard to kind of imagine yet, that could do that is different than all those protocols, because it doesn't require the integration to be between your own two contracts on both sides. It can also open to some kind of development that would allow you to verify things on multiple blockchain in a single transaction to do something. That's why it's kind of hard to imagine at first, but I think there's a lot of applications that can come out of that, essentially.
Excellent. Thank you, David. And so we have here, how does CTC and ATC sort of work or interact or are related together?
Yeah, I'd be happy to take this one. If the listeners were listening with attention, they would have probably caught it that Dave already answered this question, I believe, in his part, but yeah, I'll do it again. So CTC is the, so to speak, ecosystem token inside Creditcoin chain. So we use it to pay the gas fees on Creditcoin chain. And ATC is something that we're building. So it's the utility token of the Attestcoin. It's used to stake the funds for the attesters, or to give rewards to the operators who are going to be doing the attestations and stuff. And yeah, essentially CTC is the global token, so to speak, and ATC is more on the Attestcoin side, so Attestcoin centric token. Those are the two things. Yeah.
All right. And so we went over those here in the past couple slides. So we're going to move here to where can we start? So we have documentation that you can see the link here, and we have some repositories as well that you can clone or browse and start from. We have some examples in there that you can adapt for what you would want to test. We also have the faucet on Discord. If you prefer, we also have some recordings. So we have some videos that we start from pretty much from the start, like as in like what can it do and how to get going. And we also have some videos that are a little bit more advanced. I believe we have a bridge example there that we have a tutorial that you can start from and modify from there. And you can also stay in touch with the project, and so through the same ways, similar ways to stay in touch with Creditcoin, so creditcoin.org. We also were on Twitter, Discord, and the blog. And that concludes the discussion. Thanks for watching.